On a fine night, the greatest physicist of all time, Sir Isaac Newton, was busy with his work in physics. Suddenly, he encountered an issue, and felt the need to solve it with a new mathematical framework that simply didn't exist at that time. At that moment, he didn't know that it was going to be one of the greatest breakthroughs in the field of mathematics. The year was 1665, and a devastating plague had swept through England, claiming lives and sending waves of fear and isolation across the land. Universities closed their doors, and students and scholars alike were forced into seclusion to avoid the deadly contagion. Newton returned to his childhood home, a modest farmhouse surrounded by sprawling orchards and tranquil fields. It was in this period of enforced isolation that Newton's mind wandered beyond the confines of existing knowledge. One crisp autumn afternoon, as he sat beneath a sprawling apple tree, he observed the rhythmic dance of the falling leaves and the gentle sway of the branches. His thoughts turned inward, contemplating the forces that governed these natural phenomena. Newton had always been curious, even as a child. His mother would often find him tinkering with sundials and water wheels, trying to understand the world around him. Now, as a young man, his curiosity had deepened into a relentless pursuit of knowledge. Sitting under the apple tree, Newton's thoughts drifted to the stars and the planets. He pondered the work of Johannes Kepler and Galileo Galilei, who had begun to unravel the mysteries of the heavens. Yet, there was something missing, an underlying principle that could tie their observations together. As he watched an apple fall from the tree, a thought struck him with the same force as the fruit hitting the ground. What if the same force that caused the apple to fall also governed the motion of the planets? This simple observation sparked a series of questions in Newton's mind. He began to think about motion, forces, and change in a new way. Newton started by trying to describe the speed of a falling object. When he did this, he found that the speed of a falling object increases every second, but that there was no existing mathematical explanation for this. The issue of movement and the rate of change had not yet been explored to any significant degree in the field of mathematics, so Newton saw a void that needed to be filled. Over the following months, Newton's small study became a hub of intense intellectual activity. By candlelight, he scribbled equations and diagrams, filling pages with his thoughts. He developed a new mathematical framework, one that could describe change and motion with unprecedented precision. This framework would later be known as calculus. Meanwhile, across the Channel in Germany, another brilliant mind was at work. Gottfried Wilhelm Leibniz, a philosopher and mathematician, was independently developing his own version of calculus. Leibniz's approach was different in notation and methodology, but equally powerful in its ability to describe the changing world. As Newton and Leibniz continued their work, the plague's grip on England began to loosen. Life slowly returned to normal, and the universities reopened. Newton emerged from his isolation with a profound gift to the world. His development of calculus was a monumental achievement, one that would influence generations of scientists and mathematicians. However, the story of calculus did not end there. As Newton's and Leibniz's works became known, a bitter controversy erupted over who had been the first to invent this groundbreaking mathematical tool. Accusations of plagiarism flew, and supporters of each man fiercely defended their hero's priority. The debate became one of the most famous disputes in the history of science, with lasting impacts on the scientific community. Despite the controversy, both Newton and Leibniz made indelible contributions to the field of mathematics. Their work laid the groundwork for a new era of scientific understanding, one that would revolutionize physics and mathematics. Isaac Newton's time under the apple tree was more than just a moment of inspiration. It was a testament to the power of curiosity and the human mind's ability to unlock the secrets of the universe. In the quiet countryside of Woolsthorpe, amidst the falling apples and rustling leaves, the seeds of calculus were sown, forever changing the course of history. Today, Newton's legacy continues to inspire and drive innovation in fields as diverse as physics, engineering, economics, and beyond. His work reminds us that curiosity and dedication can unlock the secrets of the universe. That's how Newton discovered calculus. Now, click here to uncover 10 surprising facts about Newton you probably didn't know.